This video will be about filtering, which is useful for viewing a subset of data that matches certain criteria. And it looks like this. So here we have our example application, and we're going to click on the search bar in the top right and type in a search term. Then we'll hit enter, and the application will make a request to retrieve the posts matching our search term. We'll go through a short loading experience, and once the request is fulfilled, we will see a list of posts that contain the term we searched for. The core challenge here is really preventing action reducer explosion, meaning that while sending a query to the server is fairly straightforward, the question is whether you can do it in a way where you don't have to add additional actions and reducers for every different type of question you need to ask. So let's look at how Lore handles that. So here we have our application, and we want to render the results of a query. So let's dive into the component responsible for doing that. This component is going to render our list of posts. And at the top of this component, we're calling getState as part of the lore.connect decorator and requesting the list of posts where the author ID and title match the provided criteria. The first thing Lore does is alphabetize the where clause and stringify it. And what this does is that it creates a unique key that represents this query and that will be identical every time regardless of the parameter order within the where clause. Lore then takes that query key and looks in the store's state to see if the query has already been asked. For this example, we're assuming that no component has requested this data yet, so we're starting off with an empty data store. And because of that, following the pattern for this decorator, Lore will then invoke the action responsible for retrieving that data. So here's our component again, and since the data couldn't be found, it invokes an action creator to fetch the data. So next, let's dive into the action. Here is an example action creator for handling this request. It expects a single parameter, being the query we're asking, and then it instantiates a posts collection, which gives us an instance that knows how to communicate with the posts endpoint. We'll dive into actions in more detail in the upcoming video about the abstraction tiers that Lore uses to build the blueprints, but for now, you just need to know that this instance understands how to communicate with REST API endpoints. From there, the action then invokes the fetch method on the collection, passing in the query we want to ask, which causes a GET request to be made to the API server. And then we dispatch an action, shown on the right, to notify our application that the request is being fetched. Note that we include the query as a property in the action that gets fired. So two things just happened. First, a request went out to the API server. And the second is that an action was dispatched to signify that the request is being fetched. So let's dive into the store next to understand what it does with that action. Recall that the way the store works is that we take the initial state in the store, and then reducers process the action, and we end up with a final state that the application is notified about. So our initial state in this case is empty since we have no data. And our action declares that a request to fetch our query has been sent out. What happens next is that the find reducer looks at the query and knows that it should associate it with the corresponding payload. Once that happens, we end up with this final state where the value for state.post.find is an object, where the key is the query, and the value is the corresponding payload. So now, when our application is notified of the change, our component will once again request all posts matching that author ID and title. But this time, the data will be in the store, so no action will be fired. Instead, the component will take the data it finds and show a loading experience to the user. So now we're going to fast forward in time to when the request we sent out comes back from the server. Taking a look at our action creator once again, here we have our API response in the top right, and when it returns, our promise will be fulfilled, and our action creator will dispatch a new action. Notice that this time, we change the state to resolved, and our data field now contains the data we received from the server. So once again, we dispatch the action and dive into our store. This time, our initial state contains the data declaring our query was being fetched. And our new action has the data we received back from the server, letting us know that our query was resolved successfully. And because the query key is the same, we know that we can replace the old data with the new data, and we get our new state. And now the application is once again notified that our state changed, and the component updates the view to reflect the data we just received from the server. So that covers how filtering works in lore at the moment. Let's talk about some known areas where it needs to improve. So the syntax right now is centered around exact matches. Whatever you pass to the where clause is sent directly to the server. This works fine for simple filtering, like querying by user, but not for more complex filtering, like text searches or finding data within a certain date range. To support that, this interface needs to be expanded to include a more complex query syntax, such as give me all the posts with a title that starts with Bako. The second known area for improvement is what I'm calling language mapping, for lack of a better term. You see the need for this situation arising when the property names used in the client side don't directly map to the property names used by the server. And this is fairly common, especially for front-end experiences that have been around during a period where the API underwent a lot of change. So this feature would allow you to map the word you use on the client side, like name in this example, to the property the server expects to see in a query, which would be title in this case. So, to review, this is important because it's a poor experience to make users mine through large data sets, so we want to provide them a way to ask the questions they need answered. The core challenge is preventing Action Reducer explosion, and the approach that Lore takes is to stringify the query and use it as a key in the find reducer. Future improvements will include an advanced query syntax and the ability to map across language differences between the client and server.